Greetings and salutations to all you YouTubers out there. Today we're going to be doing more applications using logs and exponential functions to help us out with growth and decay. This can be used in carbon dating or half-life for any type of element. It could also be used to determine bacteria or viral populations or anything like that, or just general populations in animals or anything like that. So some real-life application, more so than like graphing a linear function or something like that. Anyway, got a definition of what half-life is. You probably already know what half-life is. It's just the amount of time something takes for it to become half of what it was at the beginning of that time frame. So let's go and get started. Got this equation up here. The y sub t is just the final amount. Y sub o is the initial amount, starting amount. E is e. K is going to be our constant. We'll talk about that here in a second. T is time. Could be hours, minutes, years, whatever the situation calls for. Okay, so the first thing is it says a certain radioactive substance has a half-life of 248. How much of a 10 gram sample will remain after 150 years? So we don't have enough information. We don't have that K constant, so we're going to have to come up with one. And to do that, we can't just say, oh, it's 5 or it's 2 or something like that. So we're going to use our algebra skills to determine what that K is for this particular problem. So to do that, we're just going to pick a number. I'm going to go ahead and go with 4. I'm going to start with 4, so that's my initial amount. My E is E, I don't know K, and it says my half-life is 248. So there's my half-life. But remember, after 248 years, it's going to be half of this, so half of 4 is 2. Okay, and now it's just a simple problem of solving 4K. So to do that, we're going to first divide by 4. So I get 0.5 or 1/2 equals E to the 248K. And the next thing I'm going to do is take the natural log of both sides. So I get natural log of 0.5 equals the natural log of e to 248k. The reason why we're doing all of this is so that 248k can come down here. So I get natural log of 0.5 equals 248k. Remember, natural log e cancels out, then I'm going to divide by 248. So in my calculator, do natural log of 0.5 or 1/2 divided by, what was my number there? 248. So that's my K, that's my constant, negative 0.02794. Now I urge you to not round until the very end. So I'm just going to kind of keep that in my calculator. So my K is, I'm just going to say equal to my calculator number. All right. Okay, so now I want to figure out how much is left after 150 years. So now I don't know what I'm ended with. That's what I'm trying to find. I know my starting amount was 10 grams. I know E. I know my calculator number. I'll just kind of do a couple places. We'll just say negative 0.003. But remember, don't round. Negative 0.003. But for the sake of writing this down, that's what I'm doing. And then times 150, because those are my years. Then let's just plug and chug it. So what I would do is I would first take that this number, multiply by 150, because I'm going to end up doing that anyway. Then I'm going to take e to that power. So e, and then watch my key strokes for a second, and then the negative button to get this answer. It gives you our last answer that was on our calculator. And then, so that's what all this gobbledygook is, and I'm just multiplying by 10. So times 10. So my answer is 6.576. So 6.576, and then we have grams. I don't know how you want to say that, grams. Boom. 6.576 grams after the amount of 150 years, we get that amount. Okay? All right, the last problem, we only got 2 here, so it's going to be quick. Says the number of bacteria in a certain culture has an initial count of 500. So we know our starting amount is 500. Number triples every 3 hours. I still don't know K, so I got to find what K is. So in this case, I'm going to use that 3-hour thing to my advantage. So triples every 3 hours. So multiply that by 3, get 1500. Started off with 500. I don't know E, or I do know E, so I don't know K, and my time says number 3 hours, so I got that. So once again, just to practice and solving for K. Divide both sides by 500, I get 3 equals e to the 3K. Take the natural log of both sides. And natural log of e cancels out, so then I get k is natural log of 3 over 3. Once again, I would just leave this in our calculator. If you want to store it, that's cool, or just don't do any math after this. So 0.366, I still don't recommend rounding, excuse me, rounding until the very end. All right, now I want to see how long it's going to take to get to 2,000. So 2,000 equals my initial amount, e, non-rounded number, and then t. So first thing we do is divide both sides by 500. So I get 4 equals e to the 0.366 blah, 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 t. Take the natural log of both sides, and then divide. So I'm going to end up doing natural log of 4 divided by 0.366 blah, 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 blah equals t. So natural log of 4 divided by that number, 0.36660, and I get 3.87, sorry, 3.786. And that's hours, right? Cool. That's all I got, guys. Good luck. See you tomorrow. Oh, by the way, the homework is not the back of the notes. The homework is that other page. Okay? Good luck. See you later. Bye.